One of the most common and economical ways to insulate a wall is using fiberglass bats, but how you install insulation is critical to the wall's overall performance. In fact, the wall should be insulated much like we see here. There's no voids or compressions. The insulation fully fills the cavity. It's fully lofted. It's in touch with the exterior sheathing, and it will be in touch with the drywall. Well, with me today is Joe Rigo, who is a building science educator. Joe, what are the areas that builders need to focus on in terms of some of the more problem areas that you see in your day-to-day business?
Well, Steve, the insulation manufacturers manufacture the insulation to be common framing widths, such as 16 or 24 inch on center. We know that greater than 40% of all the framing in the houses are odd space framing. That makes the insulation installer a pattern maker.
So, Joe, there's a good example of that over here.
Great example. The insulation contractors installed the insulation to fit perfectly in this narrow cavity. You'll notice that there's no compression, no voids or gaps, and the insulation touches all 6 surfaces that you referred to earlier.
Now, another area of concern is areas that do not get insulated before the sheathing is installed.
There are some areas, for example, the common wall between the garage and the living space oftentimes is not sheeted prior to the insulation contractor being there. So the insulation contractor needs to use something with a facing, such as craft face bats, to staple them in to ensure that the wind doesn't blow them out.
Also, I suppose where corners intersect, sometimes the framing techniques are such that they just don't get insulated.
They don't. Depending on the framing technique that's used, if the builder's using something like California corners, we can insulate behind those corners. If there is a framing technique that doesn't allow the insulation contractor to insulate there, basically we have a void that the insulation contractor cannot address.
What about electrical areas?
The electrical areas are a great concern because behind the electrical boxes it's difficult to install the material. The material should be installed behind the electrical outlets, again not having compression, but also splitting for wires. The wires are an obstruction in the cavity, so the insulation installer must split the bats to fit both behind and in front of the wires.
What's your thoughts on plumbing?
Plumbing can be a difficult area to insulate correctly. We need to make sure that, particularly in cold climates, the insulation goes on the exterior surface of the wall, between the pipe and the exterior surface.
Another area, bathtubs. They often get overlooked.
Bathtubs and shower stalls need to be pre-insulated prior to the installation of the material itself.
Rim joists?
Actually need to be insulated to the correct R value. The same R value that's installed in the exterior walls needs to also be installed in the rim joists themselves.
And that's an area that oftentimes we see problems with, where you really see a lot of compression and the insulation really doesn't adequately fill the cavity.
It either doesn't fill the cavity completely or it's overcompressed and not fit correctly in the cutting.
Joe, what's been your experience with knee walls?
Knee walls are an area that are difficult to insulate. We now need to look at an R19 as the minimum insulation value for the insulation. We also need to mechanically fasten or support the insulation and avoid compression wherever possible. We may need to mechanically fasten the insulation in unfaced or friction fit bats using something like netting. The insulation must still be in full contact with the air barrier, which is most commonly the drywall. We recommend an air barrier on the back side or the attic side of the space. The insulation also must be secured above the knee wall so that loose fill insulation will meet the same depth and density requirements to achieve the R value desired.
So, Joe, another way to insulate walls, of course, is loose fill insulation. Why don't you go over the common ways that we do that with fiberglass?
There's a couple of different ways to do that. One of the more common ways is to apply a fabric to the wall and then insert a nozzle and blow dry fiberglass in behind the wall cavity, filling up the cavity perfectly. We need to also make sure that they meet or exceed the manufacturer's weight requirements per square foot, ensuring that the homeowner gets the R value that we charge them. If they would density sample early on in the jobs, we find nationally what they typically do is actually over-install the amount of insulation that's required to get the minimum R value. So if they're careful and will density sample early on in the job site, it will set the standard for the rest of the job.
Skylights?
Skylights are difficult to install the insulation correctly. Because of the framing techniques that are used in framing the skylights, it makes it difficult for the insulation installer to secure the bats to the skylight itself.
And how do you recommend it be done?
I most commonly see actually craft face stapling of the bats, and actually they'll put the vapor retarder towards the warm in winter side and staple through the bat.
And is that inset staple, or are you recommending face stapling to the actual truss?
Well, anywhere we can face staple, it will allow us to keep the vapor retarder intact. So that would be my preference, but it depends on the framing that's actually used.
So if they're actually gluing up drywall, you probably want to use a friction fit bat there?
A friction fit bat would work very well in that application.
Well, Joe, great information. Thanks for being here.
Thank you, Steve.